Welcome to This Explainer. Today, we're jumping right into one of the absolute greatest geographical mysteries of our planet. Have you ever stopped to wonder why the Middle East, a region that's mostly covered in these vast, dry deserts, is somehow sitting on top of an absolute ocean of oil? It's just an incredible story. It's a true geological detective story, one that bridges deep time, shifting continents, and modern human history. So we're going to unpack exactly how a few specific countries essentially won the geological lottery and how that ancient history literally shapes the world we're living in right now.
Okay, so let's start with the most fundamental question here. Where does oil actually come from? I mean, we use it every single day, right? To fuel our cars, heat our homes, manufacture our goods. But if you had to trace that liquid black gold back to its absolute origin, where did it begin? I'm going to bet your first thought might involve a certain prehistoric creature, which actually brings us to a really massive misconception.
The truth is actually microscopic. You probably learned in school that oil comes from dinosaurs, right? Massive, giant reptiles getting buried underground. And honestly, it sounds totally logical. Massive animals should create massive fuel reserves. Well, scientists have actually done the math on this. Even if every single dinosaur that ever walked the Earth somehow perfectly converted into oil, their total combined biomass wouldn't even come close to explaining the colossal oil reserves we've discovered. Not even close. The microscopic reality is that our oil comes from unimaginable quantities of tiny, almost invisible marine organisms. We're talking plankton, algae, and bacteria. You could literally fit millions of these things in a single drop of seawater.
Section 1. The scene of the crime. Deep time.
To really understand how these tiny little microbes fueled the modern world, we have to travel way back to the Mesozoic era and look at how our planet has totally transformed. 250 million years ago, Earth looked nothing like it does today. We had one massive supercontinent called Pangaea, and separating these huge land masses was a mighty, warm, shallow sea known as the Tethys Ocean. Over millions of years, as those continents slowly drifted apart, the nutrient-rich currents of the Tethys Ocean just compiled staggering amounts of dead microscopic organisms and algae, and they compiled them exactly in the area that would eventually become the modern-day Persian Gulf. So the Middle East we know today, it was entirely underwater.
But here's the thing. Just having a bunch of dead plankton isn't enough to make oil. Something very special happened at the bottom of the Tethys Ocean. The waters down at the seafloor were anoxic, which means they had virtually no oxygen, and this is an absolutely crucial point. Because there was almost no oxygen down there, the dead organic matter didn't rot away like it normally would. Instead, it stayed perfectly preserved as it settled on the seabed, slowly getting buried under endless layers of mud, sand, and salt over millions and millions of years.
Section 2. The vault. Geological mechanics. Okay, so we have our perfectly preserved organic matter, but it's still just dead algae. So how does that actually turn into fuel? Well, the recipe requires some pretty extreme conditions. As the organic material gets buried under literally 2 to 4 kilometers of heavy sediment, the pressure just becomes immense. And of course, because the Earth's interior is hot, the temperature rises. When this deeply buried organic matter hits this magical zone we call the oil window, which is between 60 to 120 degrees Celsius, it basically bakes. The heat and pressure first transform it into this waxy substance called kerogen, and then it literally cracks those molecules apart into liquid crude oil and natural gas. It's just an incredibly slow, magnificent cooking process.
But here's where it gets incredibly tricky. Brand new oil is actually lighter than the salty water that's trapped deep in the surrounding rocks. So, driven by buoyancy, it naturally wants to float upward through the rock fractures. If it just kept floating, it would eventually seep right out onto the surface and just be lost forever. To actually form a massive usable oil reserve, you absolutely need 2 things to stop it in its tracks. First, an upward folded rock layer that acts like a dome or a natural trap. And second, an impermeable seal perfectly placed on top, something like thick shale, salt, or clay, that the oil absolutely cannot squeeze through.
So, you might be wondering, what built these massive underground domes and traps precisely in the Middle East? Well, it all comes down to plate tectonics. Our continents are essentially just floating on the Earth's melted liquid center, constantly shifting at a speed of about 1 to 13 centimeters per year. Now that sounds incredibly slow, right? But over millions of years, the force generated is just unimaginable.
And this brings us to the ultimate geological jackpot. The Arabian Plate slowly but incredibly powerfully collided with the Eurasian Plate. This massive, ongoing collision literally folded and faulted the rock layers, pushing up the Zagros Mountains, and brilliantly creating those perfect dome-like underground reservoirs we were just talking about. This tectonic activity built the ultimate geological vault. It locked all that rich, cooked oil from the ancient Tethys Ocean securely underground.
Section 3. The evidence. Life versus deep Earth.
Now, in the spirit of good scientific inquiry, how do we know for absolutely sure that oil comes from ancient marine life rather than just, forming naturally deep inside the Earth's mantle? Well, the data totally dismantles that abiotic theory, the idea that oil forms without life. Scientists have found these incredibly complex molecules in crude oil called biomarkers, specifically things called steranes and hopanes. These are quite literally chemical fossils that perfectly match the cell walls of ancient algae and bacteria. There is literally no known process deep inside the Earth that can create these without life. Furthermore, living organisms strongly prefer using the lighter carbon-12 isotope. And when we test crude oil, it shows that exact same strong preference for carbon-12. So the rock layers, the biomarkers, the carbon isotopes, they all independently prove, for sure, that this fuel is the legacy of ancient microscopic life.
Section 4. The Middle East Advantage.
Knowing all of this, let's zoom out and think about the modern world. The numbers here are truly mind-boggling. The crucial takeaway is this. The 10 countries with the highest crude oil availability in the Middle East, we're talking places like Saudi Arabia, Iraq, Iran, Kuwait, and the UAE, together, they make up only 3.4% of the Earth's entire landmass. Yet somehow, this tiny fraction of land holds an astonishing 48% of the world's total crude oil reserves. This is exactly why geologists call it winning the geological lottery. It was that totally unique combination of the Tethys Ocean, the anoxic seafloor, and the tectonic plate collisions that created this crazy anomaly of abundance.
But wait, it actually gets even better for the region, because not all oil is created equal. Let's compare the Middle East to Venezuela, for example, which actually holds the single largest proven oil reserves on Earth. In places like Saudi Arabia, the geological conditions preserve the oil as what's called light and sweet, meaning it flows really easily, it has low sulfur, and it's super cheap to refine into gasoline. In stark contrast, over in Venezuela's Orinoco Belt, underground microbes literally ate the lighter parts of the oil over time. They left behind this thick, heavy, sour tar that is incredibly difficult and expensive to process. So the Middle East didn't just get a ton of oil, they literally got the best quality oil.
Section 5. The payoff. Modern geopolitics.
This unmatched abundance of high-quality oil inevitably completely reshaped global history. The year 1960 is a massive, massive turning point. As the modern industrialized world rapidly expanded, the global thirst for oil simply exploded. Western companies realized the sheer staggering scale of the Middle East's reserves and began pouring heavy investments into the region for exploration and production.
In response to this profound external influence and all this wealth generation, oil-producing nations in the region took action. They formed OPEC, the Organization of the Petroleum Exporting Countries. This was a really strategic move by these nations to coordinate their production, manage the massive economic boom they were experiencing, and ultimately gain control over the pricing of their own natural resources. Think about that. The ancient geology of the Tethys Ocean was now directly dictating global economics, energy markets, and international relations. The story of Middle Eastern oil is a journey through deep time revealing the interconnectedness of geology and human history. I mean, it's so true. Every single time you fill up your car, you're utilizing the compressed energy of trillions of microscopic marine organisms that lived 250 million years ago, perfectly trapped by the slow collision of continents. The wealth, the geopolitics, and the rapid industrialization of our modern world are just inextricably linked to the slow, invisible forces of geology. But, of course, this ancient process brings us face to face with a pretty harsh modern reality, because it takes millions of years, intense heat, and incredibly specific geological traps to make this oil. It's effectively non-renewable on any human timescale. We're consuming it far, far faster than the Earth could ever possibly replenish it. Recognizing this rapid depletion, along with the very urgent need to mitigate climate change and greenhouse gas emissions, the global energy market, and that absolutely includes the Middle East itself, is now being forced to heavily diversify into renewable energy like solar, wind, and geothermal power. Which leaves us with this final, really profound question to consider today. The Middle East's immense wealth and its strategic global importance were literally built on the back of the ancient Tethys Ocean.
So as human innovation accelerates our transition away from these deep-time fossil fuels, how will this massive shift reshape the future geopolitical landscape of the region? It's a fascinating next chapter in a story that began hundreds of millions of years ago. Thank you so much for joining me on this explainer. Keep asking questions, and I'll catch you next time.